Greetings, traveler. I'm the calculus cleric, and today we'll be going over parametric equations. The problem is a particle follows the trajectory x of t is equal to 14t cubed plus 2t, and y of t is equal to 20t minus t squared. A quick recap on parametric equations. Basically, take our regular y equals function, split up the x coordinates and the y coordinates, give them their own separate function, and link them together with time. This is useful for helping you to see like the trajectories of things, where the graph is going to go next as we increase or decrease the time. From that, we will look at part A. What is the particle's maximum height? So for part A, what we want to do is figure out where this particle goes the highest. And let's think about this like, I don't know, how about a ball? How about some quick physics here? Say I have a man that looks like this. I know, excellent drawing. And then he has a ball in his hand. And when we throw the ball is going to do an arcing path because no ball on Earth is going to go and sail off into infinity because we have something called gravity. Doesn't let our balls fly forever, but also keeps us from flying off into space. So that's good. What's the particle's maximum height? Well, as you can see, it makes this parabola shape. And when I draw the parabola out, the maximum height is at the very top of the parabola. Kind of like common sense. But to figure this out using parametric equations, there are two ways to do this. Either we find the vertex or we find the derivative. And I'll explain why you can do either of the two. When you find the vertex, you're basically finding the center of the parabola. And because a ball thrown is pretty much the same thing as an inverse parabola, our maximum point will be exactly at the vertex in the middle of the parabola. The reason why we're using a parabola here is because it gives us that our y of t is equal to 20t minus t squared. So it's telling us our y values are changing like how a parabola does. This is the equation of a parabola. We can ignore the x coordinates for now, since we're only caring about what's happening to the y, the height. So that's one way, is to find the vertex. The other way is to find the derivative of this line, because we know that when the derivative is 0, if I take derivatives anywhere else, it's not going to be 0, but at the maximum point, at the vertex, it will be 0, because at this point, the ball has stopped changing direction, so it's flying faster, and then it slows down, reaches its top peak, stops, and then changes directions, begins to increase speed again, and definitely not an arc, but you get the idea. So those are the two ways. I'm going to work through both of them. First is we find the vertex. So the standard equation for the vertex is negative b over 2a. We actually don't have to care about the y value. We're simply only looking for the x variable. X is in quotation marks because it's not really x. We're actually finding t because it's in terms of t, like a basic parabola is in terms of x, but we'll just change that in terms of t. Same concept. Negative b over 2a. So we'll plug in our b value, which is this, and then our a value, which is that. So our a value is equal to negative 1. Our b value is equal to 20. Plug that in there, should give us our t at the vertex. 20 over negative 2. Simplifying that gives us 10. So our t is equal to 10 seconds, because it gives us seconds, t in seconds. And then from there, we can use this to figure out what our maximum height is. So how do we do that? Well, basically, at this t point, we know that it's going to be at its highest, right? So we just simply plug that back into the y of t parametric equation to get the highest point. Y of 10 is equal to 20 multiplied by 10 minus 10 squared, 200 minus 100, which is equal to 100. Distance is in centimeters, So 100 centimeters is its highest point. Okay, so the second thing we can do, find the derivative. So we take the equation, the parametric equation, they give it to us, and then we find d over dt of that. So y prime of t is equal to 20 minus 2t. That is our derivative. And then from there, we have to figure out where does it level out. So where does it reach its highest? We know at the highest point, the derivative will be 0 because, like I explained before, it stops changing. So 0, set that equal to 0, and then is equal to 20 minus 2t. Solve that out with algebra, which gives you t is equal to 10 seconds. Same as the result above. And once again, you do the same thing, plug it back into the regular y of t, because we're not looking for how much it's changed, we're looking for its actual position, which is equal to 100 centimeters once again. So we know that's consistent both ways. Work, our maximum height is 100 centimeters. Okay, and now part B. When does the particle hit the ground and how far from the origin does it land? Basically, this question is also two parts. So they're asking us when it hits the ground and they're asking how far. Figure out when it hits the ground, you'll notice that our y is going to have to be 0 because it hits the ground when there's no more height. And to do that, we know that this thing makes a parabola. So if we plot that on an xy coordinate, we'll notice that when it hits the ground, well, that's going to be 0 height, no height at all. So those are what we call x-intercepts. Well, let's call them t-intercepts in this case, seeing as it's no longer in variables x and y, but t and y. So our t-intercept, what time will the height be 0? So to solve for that, we just simply set y is equal to 0, because once again, height needs to be 0. And then we solve for this using algebra. What I'm going to do is factor out a t. 20 minus t is equal to 0. And that gives us two answers. T is equal to 0 and t is equal to 20. Okay, but now you notice still two times. Okay, so how do we know at what time did it hit the ground? We can think of this like, let's say, a cannon. Let's draw a cannon at the origin. Very good looking cannon. And our cannon launches the ball directly from the origin. It fires, and then our cannonball streaks off, and then it'll eventually land again at the second at t-intercept. And that one will be 20 because it's fired at 0 and it flies up and it hits the ground again sometime after 0. So it's not when it's shot, it's when it lands. So we'll know it'll be the later one. T is equal to 20. Okay, now the second part. How far from the origin does it land? So we can do the same thing like we did for the y of t when we looked at how high it went. We can simply do that with x of t because now it's asking for horizontal distance. How far did this cannonball travel, or ball, however you think about it, particle. How far did this particle travel? Basically, we're looking for the horizontal motion. And to do that, we simply plug the t of equals 20 that we found back into x of t. X of 20 is equal to 1/4 20 cubed plus 2 multiplied by 20, which is equal to 1/4 multiplied by 20 cubed, which is 8,000, plus 2 multiplied by 20, 40. We'll simplify that, which is 2,000, 2,040. 2040 is our answer. And the distance is in centimeters. So we traveled 2040 centimeters from the origin.